In this video, we'll be discussing intercepts. The point at which the graph crosses the x-axis is called the x-intercept, and the point at which the graph crosses the y-axis is called the y-intercept. With intercepts, the graph doesn't necessarily have to cross either of those axes. It could just touch the axis, and that would be an intercept as well. In order to find the x-intercept, we let y be equal to 0 and solve for x. The x-intercept is written as the ordered pair x, 0. To find the y-intercept, you let x be equal to 0 and solve for y. The y-intercept is written as the ordered pair 0, y. The reason that we let y be equal to 0 when finding an x-intercept is if you look at this diagram here, the points, these intercepts, where we're hitting the x-axis, and anywhere, any of these would be x-intercepts, the y-coordinate is always 0. If the y-coordinate was anything other than 0, it would move us either above or below the x-axis. Same with the y-intercept. When finding the y-intercept, we always let x be equal to 0, because in order for a point to be on the y-axis, we must have moved 0 in the x direction. So let's identify the x and y-intercepts for some equations. Our first one is x squared equals negative y plus 16. To find the x-intercept, we always let y be equal to 0 and solve for x. This will give us x squared equals negative 0 plus 16. We know that negative 0 is the same as just regular 0, so 0 plus 16 gives us 16. To solve for x, we'll now use our square root property and take the square root of both sides. We get x equals, don't forget we have a plus or minus anytime we use square root property, so we get plus or minus, and then the square root of 16 is just 4. We have two x-intercepts, one occurring at x equals positive 4, one occurring at x equals negative 4. But remember, intercepts always should be written as ordered pairs. So our x-intercept, 4, 0, and negative 4, 0. Moving on to finding the y-intercept. Here, we'll let x be equal to 0 and solve for y. 0 squared gives us 0. Adding y to both sides, we get y equals 16. We have just one y-intercept, and it's the ordered pair 0, 16. Next, we want to find the intercepts for the equation y equals the absolute value of x minus 8. To find the x-intercept, we let y be equal to 0 and solve for x. Here we have an absolute value equation. Remember, when solving an absolute value equation, you start by isolating the absolute value, which it is, and then we apply the property where the inside of our absolute value is either equal to the constant or it's equal to the opposite of the constant. We know that 0 and negative 0 is the same thing, so this will consolidate down to just a single equation, x minus 8 equals 0. Solving for x, we get x to be 8. This makes our x-intercept the ordered pair 8, 0. To find the y-intercept, we let x be equal to 0 and solve for y. This gives us y equals the absolute value of 0 minus 8. Now, this is not technically an absolute value equation because the variable we're solving for is not inside the absolute value. So all we're going to do is order of operations on the right side of our equation. Y is already isolated. This will be y equals the absolute value of -8, and the absolute value of -8 is +8. Our y-intercept is the ordered pair 0, 8.